Hi Pre-Algebra, we are still in Chapter 3. We're working on operations with rational numbers, but now we're going to talk about adding and subtracting like fractions. This shouldn't be too hard, but do watch for the nuanced differences as we're dealing with variables and negative and positive numbers. Our sole vocabulary word today is like fractions, and basically those are fractions with the same denominators or with common denominators. So obviously if I have 1/12 and 3/12, these are considered like fractions because the denominators are the same. Whereas if I have 1/12 and if I reduce 3/12 and I got, let's say, 1/4, these are no longer alike. So today we're going to be looking at problems or problems and questions that deal with common denominators. So let's take a look at some examples. Just as the last lesson, you'll see that there are going to be some problems that I expect you to try on your own. The answers will be given at the end of the lesson. So let's take a look at these first two examples here. We've got 7/10 plus 8/10. When we're adding numbers that are, or fractions that are alike, and the denominators are the same, we just add the numerators and the denominator stays the same. So our denominator is still 10, but when we add 7 and 8, we get 15. Since our directions ask us to write our answer in simplest form, what we need to do is actually see if we can reduce this and see if we can write it as a proper fraction, as we have an improper fraction here where the numerator is greater than the denominator. When I look at this, I recognize that 5 goes into both 15 and 10, so that's going to be my first step in reducing. 5 goes into 15 3 times, 5 goes into 10 2 times, so I end up with 3 halves. I can rewrite that as a mixed number, and that will be 1 and 1/2. So my answer to the first part is 1 and 1/2. Pretty straightforward, but when we look at this next one, now we have a negative value in here, and I know we didn't do this before. So when I have 5/8 plus -7/8, I'm going to treat this the same way I do any sort of pairs of numbers that I'm adding with different signs. I'm going to subtract the two numbers and take the sign of the higher. Indeed, the denominator stays the same, so I'm still dealing with an 8 at the bottom, but when I add 5 plus a -7, my answer is -2. So now I have -2/8, or the preferred way to write this is -2/8, and I will reduce my fraction of 2/8, recognizing that 2 goes into the numerator and denominator, and I get -1/4. Please pause here and try the next two problems. Here in example 2, we're looking at adding mixed numbers. If you notice, when you in the example that we have, our denominators are the same, which is really good. What we're going to do is add the whole numbers together, and then we're going to add the fractions, and then we'll see if we can simplify from there. So when I add the 2 plus 3, I get 5. And then when I add the 3/8 plus the 7/8, I get 10/8. Clearly, there's something, yes, we have a mixed number, but it's a mixed number and an improper fraction. So what we're going to do is streamline this so we simply have a mixed number. 10/8 can be written as, so I'll write my 5 here, but the 10/8 can be written as 1 and 1/8. Just kidding. What I should have said is that 5 and 10/8 is equal to 5 plus 1 and 2/8, because 8 goes into 10 one time with a remainder of 2. And so we get 2/8. So what we'll do is we'll add the whole numbers together and we get 6 and 2/8. The next thing we'll do is reduce this fraction. We know that 2 goes into 8 and 2 goes into 2, and so we get 6 and 1/4. Please take a moment and try this one here. Yours is a little bit more challenging because you've got negative numbers here, but you remember the rules for adding two negatives. Just keep the sign the same and your answer will be negative. Just add and keep the sign the same. Here with example 3, we're going to subtract fractions. When we're subtracting fractions, again, we want the common denominator, which we do have, so that's a good thing. And then what we're going to do, so we've got that, what we'll do next is we will subtract the numerators. So we're looking at 3 minus 9/10. 3 minus 9, as we know, is a negative number. We're going to get -6/10. And so I can write that as -6/10. well, negative 6/10 written like that. We are going to reduce this. 6 and 10 have a common factor of 2. So when I divide the numerator and denominator by 2, I end up with the fraction negative 3/5. Please try this one. Pause here, try it. We'll look at the answers very soon. So when we subtract mixed numbers, we often get very interesting things that have to happen. It doesn't work as easy as when we add them. So let's make sure and pay close attention to this example. In example 5, we're going to subtract some mixed numbers. LaShawn has 5 1/8 yards of ribbon to border scrapbook pages. If she uses 1 7/8 yards on the page, how much ribbon is left? So we know when we're asked how much is left and we're given two quantities, oftentimes that refers to subtraction. So that's indeed what we're going to do here. So we are subtracting 1 7/8 from 5 1/8. And it's kind of tempting to think, oh, well, 5 minus 1 is 6, and then figure out what to do with the 1/8 minus the 7/8. But if you think about it, you really cannot take 7/8 from 1/8, and that's a problem. So what we'll do to deal with the fraction first in this subtraction problem is we need to borrow to help out this 1/8 become powerful enough in order for 7/8 to be subtracted from it. So when I borrow a whole from the 5, I'm not borrowing the number 1. I'm not going to add a 1 to the numerator. I'm actually looking at that 1 that I've taken from the 5 as 8/8. So now this is going to beef up that fraction so that I can indeed subtract the 7/8 from it. Let's come over here. So instead of having 5 1/8, I have 4 9/8. And then I'm going to subtract 1 7/8. Now I can deal with the fractions first and then deal with the whole numbers after. So 9/8 minus 7/8 is 2/8, and 4 minus 1 is 3. I'm going to finish this off by reducing the 2/8, which we know reduces to 1/4. So we know that LaShawn will have 3 1/4 yards of ribbon left. Our final example, example 6, we're thinking about adding or subtracting algebraic fractions, and it works actually the same exact way as when we add and subtract regular fractions. We do need a common denominator, as we have here, as every one of our examples today have had. So we know our denominator will be 10, and what happens when we add 3a plus, this is really just 1a. If I add 3a's plus 1 more a, I get 4a's. We're not done yet because we want to simplify this. We recognize that 4 and 10 both have a common factor of 2. If I divide my numerator by 2, I get 2a. Yes, the a still stays there, hangs along for the ride. And then when I divide the denominator by 2, I get 5. So the final answer is 2a/5. Here are the answers to the You Try problems. Please take a look. This is a great chance for you to determine whether or not you really understood the lesson. If these problems are not coming out right for you, you definitely want to bring them up in class the next time we get together. So friends, we've come to another end of a lesson, and as always, it's exciting and fun for me to imagine talking to you. I look forward to seeing you in class and discussing some more of the math. Let me know if you have any issues. Our assignment is as follows: pages 150 to 151, 15 to 47 odd, pretty straightforward. Please make sure and do as much of the assignment as you can when we get together. Talk to you soon.